Increasing order of dimension of time. Decay constant is by time. So dimension formula of lambda. So intensity of radiation power per unit area. Power dimensional formula. So mt power minus 3. So here force between two charges 1 by 4 pi epsilon naught q1 q2 by d square. Epsilon naught 1 by 4 pi is a constant fd square. I here is rate of flow of charge. Q is ampere into time. Force dimensional formula into L square. M L power minus 3 A square T power 4. Moment of inertia I equal to mr square, that is ml square. He is asking time dimensions. So in which order? Increasing order. So permittivity has maximum time dimensions, that is C, right? Least dimension is for intensity of radiation, that is B. B is least, C is greatest. So obviously A here T power minus 1. This is T power minus 3 here. A is T power minus 1. D is T power 0. C here T power 4. So find the area appropriate significant figures. Area here is length into breadth 10.52 into 0.041. It has 4 significant digits. So after decimal point, before non-zero digit, this 0 is not significant. So it has only 2 significant digits. So after multiplication, so it should have only minimum number of digits among the given numbers. That is 2 significant digits must be there. Do general multiplication. Here it is 43,132. Here 3.4. So we want only 2 significant digits. The followed digit is less than 5. The final answer is 0.43 meters square. Here a particle is thrown with a speed at u at an angle theta with the horizontal. When the particle makes an angle phi, when it changes, speed changes to v, it makes an angle phi. So then horizontal velocity is not affected throughout the path. U cos theta is v cos phi. He is asking v will be u cos theta into secant phi. Here it is. So applied force is applied at the free end. So tension is equal to 2 mg. Here its weight is mg. When it is moving upward, T minus mg is ma. Here we get ma, that is acceleration is g. Three identical spheres are placed touching each other. So that their centers ABC lie on a straight line. The position of center of mass from A is, so here its mass is, let us assume A as 0, 0. Its all are identical, mass will be same. Its center of mass will be at 2r comma 0. Here it is r plus 2r, 3r plus r, 4r. Its center of mass will be at 4r comma 0. So here it is, y coordinate is anyhow 0. Xcm will be m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Since all are identical, m1 equal to m2 equal to m3, let us say m. Xcm will be m into x1 plus x2 plus x3 by 3m. x1 is 0, x2 is 2r, x3 is 4r by 3, 6r by 3, which is 2r. Here, a tennis ball bounces down a flight of stairs, striking each step in turn and rebounding to the half of the height. Here it is missing the coefficient of restitution. When it is fallen from a height, after that it rebounds to a height h by 2. Here it is having coefficient of restitution. Before hitting its velocity v, it rises with a velocity ev. H square is v square by h, here is v square by 2g. So it rises with ev, here velocity is 0. 0 square minus e square v square is minus 2g times h by 2. So here h will be e square v square by g. This is new height. Right. So the coefficient of restitution he is asking. H, we know that it is v square by 2g, which is e square v square by g. So E will be, E square is half, E will be 1 by root. So a boat of mass 80 kg is floating on a still water. A dog of mass 20 kg is on the boat somewhere here, is at a distance of 10 centimeter from the shore. So this is the shore for us. So this is at 10 centimeters, 10 meters, right? The dog moves on the boat by a distance 2 meters from initially boat center of mass here, having mass capital M. Dog mass, let us say this is C given mass as 80 kg, plus 20 kg. So here, more mass is concentrated towards right. Center of mass will be towards heavier part. This is the position of center of mass. Now, dog and boat, part of one system. There is no external force. Dog is part of the system. When dog moves towards right or left, right or left, since there is no external force, no change in center of mass. So center of mass, even dog moves towards right, center of mass must be here. When it moves towards it, center of mass has to be here means boat has to move. Actually, center of mass shifts. If boat is here, dog moves towards right, center of mass will be. But since the part of there is no external force, center of mass should not shift. For that, boat moves towards left by x units. Once boat moves towards left by x units, its moment. So dog actually hits at 2 meters. Relatively, dog moves 2 minus x meters. So 5x equal to 2, x is 0.4 meters. So that is, in fact, 8 minus 2 plus 0.4. So here it is 10 minus 2, sorry. So 8.4 meters. So this is the distance of dog from the shore. A suitcase is gently dropped on a conveyor belt which is moving at 3 meter per second. Coefficient of friction is 0.5 between belt and suitcase. Find the displacement of the suitcase relative to the conveyor belt before slipping. Before slipping means its velocity becomes 0, final velocity. So then here u square is 2as. So here this is normal reaction, its weight. Force of friction is mu s into n, mu s mg. Ma here is this, A here is mu s into g. So 9 equal to 2 mu s into g is 10. Yes. Mu s, he given it as 0.5. 2 times 0.5, which is 1. So s will be 0.9 meters. A string of pendulum having a bob of mass m is displaced through 90 degrees from the vertical and then released. What is the tension in the string when the bob passes through the mean? This is mean position. From vertical it is shifted. It is length of the string. When it is here, it has only potential energy, that is mg into. When it slowly comes down to the mean position, it has only kinetic energy, that is half mv square. Since energy is conserved, we can write v square as 2g. Since it is moving in a circular path, so here is tension. So with respect to Bob view, centrifugal force T minus mg is mv square by L. So tension is mg plus mv square by L. mg plus m into v square by L is 2g, which is 3mg. Uniform circular motion with an angular momentum. So frequency is halved, kinetic energy is doubled. So kinetic energy has a formula half 5 omega square of I omega into omega or L omega by 2. We should get kinetic energy in terms of frequency and angular momentum. Omega is 2 pi f. So pi times LF. So K1 by K2 is L1 F1 by L2 F2. What he given is kinetic energy is doubled. Frequency is halved. So it is 2K1 L1 by L2 F1 by 2. Get cancelled. 2L1 by L2 is half, which implies L2 is 4L1. That is, angular momentum becomes 4 times. A satellite is launched into a circular orbit of radius. Second satellite is in an orbit of radius 1.01 period. So Kepler's law, T square is proportional to R cube. T square is sometimes R cube. Here radius change R to 1.01 R. This change is small. You can take the help of differentiation. 2 log T is equal to log K plus 3 log R. Delta T, which is 3 delta R by R. What he given is so percentage. Percentage means delta T by T into 100. He is asking 3 by 2 delta R by R into 100. Delta R is change in increase in radius, original radius 100, which is 1.5%. Here a simple pendulum, the point of suspension is now moved up with an acceleration. So y here is kt square, he given k as 1, dy by dt will be 2t, this is velocity, acceleration is dv by dt, 2 meter per second. That means, so it's moving upward with 2 meter per second square. So the net acceleration is t minus mg is ma, t equal to m times g plus a. G plus a will be effective acceleration. So now time period is equal to simple pendulum time period. 2 pi is a constant. Length of the simple pendulum also constant is inversely proportional to, that is T1 by T2 will be root G2 by G1. G2 means effective acceleration. That is G plus A by G. 10 plus 2, 12 by 10, root of 6 by 5. So T1 square by T2 square will be 6 by 5. So here metal rope of density 600 kg per meter cube has a breaking stress 9.8 into 10 power Newton. This rope is used to measure the depth of the sea. So once you take a rope, once it is completely immersed in a sea water, so the forces acting on it will be mg and upthrust. The net force acting on it will be mg minus upthrust. So mg will be metal rope when it is in air. Its density is, let us say, rho volume into density. So upthrust will be, that is volume of the water displaced, that is volume, since it is completely immersed, so volume will be same, but its upthrust is due to the liquid displaced density of water, so Vg into rho minus rho. So here he given stress, breaking stress is F net by area, that is Vg into rho minus rho W by A is equal to 9.8 into 10 power 8 Newton per meter square. So here it is volume is cross-sectional area into length of the rope into G rho minus by A, which is 9.8 into 10 power 8. G and 9.8 get cancelled out. Length is equal to 10 power 8 by rho minus rho naught. So here is 6,000 density of water 1000 kg per meter cube. 10 power 6000 minus 1000, here 10 power 8 by 10 power 8 by 5 into 10 cube. So 10 into 10 power 4, 5 by 5, that is 2 into 10 power 4 meters. That is 20 into 10 cube meter will be the depth of the sea. Better to write a soap bubble. So what will be the amount of work done? Work done to increase its surface area. Work done to increase its surface area is equal to surface tension into A. Here it is surface tension. Since it is a soap bubble, we have to consider two surfaces. That is sigma into 8 pi r square. And the volume of bubble is this. So here R cube is proportional to V because here it is work done is proportional to R square, and that R square is proportional to V power 1 by 3 whole square, which is V power 2 by 3. So W1 by W2 is V1 power 2 by 3 by V2 power 2 by 3. Volume here is 8V1 power 2 by 3. 1 by 8 power 2 by 3, 1 by 4. So work done will be 4 times work done.